Hello everybody and welcome to another episode of No Orientation Programming. I'm Joe and today we will make an Advent of Code session. I'm not into soldering today and stuff, so I'm not in the best shape, I guess. I have the flu a little bit, so we make something relaxing today. Last time. Today, I made the last example of the 2022 Advent of Code. So I don't want to make any spoilers, so I will code the 2015 version. And we have started the day 9 already. We were passing the lines of the first example, and we have transferred this to a data structure which looks like this. We have the nodes, and for every node we have a possible next destination. At first, this structure was different. It looked like this. A lot of stuff is dependent on how you keep your data organized. For example, in this case, we could make if not lists. One is member list, for example. Then we can say lists list is an object. Yes, an object value, for example. We have a lot of options here. Let's see how this looks like. Now we have here a list element, and we could say this was the first approach, I think. We could store a distance element like this. Now I think we had it like this, array value, and then append we had a value temp, and in this value we had temp source is equal to source, and then destination was destination, and we said nope, no, it was different. I tried to restore the old case we had, and it was like this. This temp, I think. Okay, we have an exception. Why? Is this possible? Yes, this was the old case. So we could organize, we are passing the lines, these lines, and we could store the information we get from these lines in this way, for example. But this was the first approach. But then in this case it isn't easy to fulfill the requirements, so we restructured the data in this way. So let's see if I can just remove this. Okay, so this is the starting point. Now what do we want? We want to have the shortest way from one point to another in a way that we don't visit one node more than only one time. So this is called, I think, Hamilton path. Yes. It looks like this. We want to visit every point only once, so we make a circle like this. And yes, that's the requirement. So I made a function that is called calculate, whatever, calc shortest, and we have a lot of ways how we could solve this, so I make it as quick and dirty as possible. So I make a list of strings. This list of strings will contain every point we visited already. Visited. And we give this function a reference to it. Because it's very easy to create a endless loop, we will limit the depth we can visit. We should not reach this point. Too deep. So let's see. Okay, now what should this function do? It should iterate over all the elements of the data structure and jump to the next possible location. And we should not jump to a location we have already visited. So iterate through objects. How is this done? Yes, with a const iterator. Let's see. We have a value const iterator iter. Yes, dists. Nope. We need to have another reference, I think. And this is called value of a reference to no, we don't need this. Let's see. Let's see. We make another function bool. Node found. What kind of node? Const char pointer node. And we have a list of strings. And we say visited begin. Come on. Visited unequal to the end iterator plus iter and come on. It is equal to node return true. So, and here we iterate over every time over our distance JSON structure. Every time we iterate over 1, 2, 3. So like this, iter unequal to dist and plus iterator. If a node found in our path visited, then which node? Iter.key or whatever. Key and value. Yes, key and value. I think it's called key and value. Yes, key, of course, key. Hmm. Mm, no. I need a node, I think. Do I need a node? Oh, recursive functions. That's the reason why I make the advent of code stuff, because I need to practice these recursive functions a little bit. So what do I want? Let's see. I want to iterate. I want to take a first step. So let's make a first step. The first step is visited point push back. No. Oh, Flavio. Hi. What's up? Are you speaking English or German? I can switch if you want. Today we are... Hi, Flavio. Thanks for the raid. English and Italian. Cool. Today we make the advent of code. Do you know what this is? And then you can speak pizza or English. Pizza. Sounds delicious. Hi, I want a promotion of your channel. Okay, what's that? That's strange. That's a bot, I think. We have just completed day 7. Day 7. Cool. Congratulations. Which one was that? 7. Ooh, yeah. That was a hard one. I think for this example, it was also necessary to use a recursive function. Yes, pretty hard. For me, it was hard, and it was not chorizo. Very cool. I completed the first part very quickly, but then I had a strange bug where the little example was right, but my with the puzzle input, the result was not correct, so I had a strange bug. bug. At first, it took me some time to find it because it was working in this example, but not for the complete example. That's very often if the small example is working, then you have a high chance that it's also working for the big example, but for the big input, but sometimes it's not working. I think yes, I'm using Vim. I'm always just using Vim and Meson to build. I have a very small setup, not a big IDE like Visual Studio or something, or Eclipse. I'm just using my text editor, no suggestions of bugs or whatever. And I think day 8, yes, day 8 is easier than day 7. For me it was. And today I tried to solve day 9 of 2015. And here we have a list of distances between two places. At least you don't have big RCEs in a browser-based one. What is an RCE? Remote code execution. Oh, ooh. Okay, yeah, that's interesting. Oh, nice. Yes, that's everything has its advantages and drawbacks. RC, remote code execution. I'm so stupid. I don't know every abbreviation. That's why using a browser something else is not a good idea. That's completely right, yeah. In the day 9 we have this list and we have to make a Hamiltonian path. That's a path. I don't know if you know graph theory, but if you have nodes that are connected to each other, you can represent them with a graph. And a Hamilton way is the node equivalent a little bit like the Euler, how is it pronounced? Yes, year 2015 and day 9. Euler-Weg. I think it's called Euler-Weg. Euler-Kreisproblem, yeah, and how is it called in English? The Eulerian path. And this Eulerian path is a little bit different. You just want to go through the nodes and use only the paths one time. And here it's the nodes. And this is also a recursive issue. And you need a recursive function to solve this puzzle. We have passed the lines already. And last time the first approach was to save the input data in this way as a list of distances, but then I switched it to a structure like this, and here we have in a JSON structure we have a list of nodes and for every list of for every node we have a list of possible targets. And if we go through the data structure, then we will calculate a path in a list, in a string list, which places did we visit already, and then you have to keep a stack of statuses and loop forever. Yeah. So the state is the trace, and this trace is saved in a string list, and then we iterate over the nodes and we check if we have visited this node already. If yes, then we say continue. This node isn't interesting for us anymore. I don't like recursions in C and C++. TCO in this length is weak as fuck. TCO, what is TCO? I'm very bad in abbreviations. Total cost of ownership. Tail call optimization. Yes, so that's possible, yeah. And I don't want to. It's very interesting. Every one that makes the Advent of Code stuff is making it in a different way, with a different strategy. Some people try to use different languages because they want to learn different languages. I think that's a good motivation. And some people want to optimize the stuff, and I just want to to get the result. So I'm not very, I don't try to be very efficient, just want to get the result, because I always code in a two-step way. At first I want to get the result as quickly as possible, and then in the second stage I try to optimize the stuff. And my main goal for 2020, I don't want to optimize my ASN solution, I just want a Stack Overflow. Yeah. Actually, yes, you can just get the solution. I don't want the final example for me will be, I want to make an multi-threaded example where I can create a lot of processes that are solving different problem sets of the Advent of Code thing. For example, in 2015 we had one, I got it on the first try. In day 4 of 2015 there was a calculation of an MD5 sum, and I want to make a little multi-threading example. Was the most difficult year. 2015 was the most difficult year. Okay. Yeah, until now it's quite okay. I'm quite curious what is waiting for me here. As you can see, I didn't know AOC before, so I'm very curious what is how difficult. No, maybe it was the most difficult. Never mind. Yeah, It's difficult for me already. So it's interesting. So at the moment we have the line passed, and the line passing, as you can see, I make it very in a cheap way. I don't use as a fancy C++ standard, no new standard. I just use the 2011 standard of C++. By the way, I learn a new language every year solving AOC. Cool. Cool. So I guess this year you are learning Rust. A lot of people code Rust at the moment. I'm watching it now. Rust was 2000. Oh, okay. Rust 2021. So what are you learning this year? Guess who? I think you mean guess what? Mm, Go, maybe? If not found. It's like the game Guess Who. Yes, Go is my guess. Go is a toiling man. Yeah, maybe. But a lot of people are coding in Go. It looks kind of fun. Worst language ever. Okay. Python. Python is one of my favorite languages. C++ and I only code in C++, and I'm a beginner Python, a Python beginner. So it's quite a lot of fun. No, I don't. You don't like Python? That's a cool high. What do you use as high level language? Ruby. I heard it. I always hear about Ruby, but I've never seen it. Mhm. Mhm, mhm, mhm. Lisp, Smalltalk, and Perl. I have never coded in any of these languages, so they are quite. Okay, so it's not brainfuck or something. It's Prolog. Oh, Prolog. This year you make the examples in Prolog. Oh, come on, what's that? Mhm. Mhm, mhm. Yeah, it's a C program. It's very hard to read. It's not about the syntax, it's about the constraint logic programming. Ah, okay. Logic programming. Is a logic programming language? What is a logic programming language? I'm completely the procedural type. Just do and do the next and do the next. That's easy for my brain. Facts. An example of a fact is cat Tom. Cat Tom is equal to true. True. Is Tom a cat? Okay. What things are cats? Stay away from logic programming. Rules. An example of a rule is if we add that rule and ask what things are animals. Okay. So that's a transitive relation somehow. Oi. Yes, it's a different thing. You have to forget everything you know. I think. That's yes. There are some. It's very interesting. Some languages are very similar to each other. Like if you take Python or C++ and all the procedural stuff, then there are the functional languages and yes, the logic programming languages. The only language I have learned that was quite different was VHDL. To you all except for the U-boots. Good evening, Vision. We are talking and programming about Advent of Code. We have finished day 8 already, and at the moment we are coding the 2015 example, day 9, and we have passed the data structure already, and although I'm using recursion very often, like in our core base class. Sorry for my English, I'm telling from Italian country, land of pizza codes. my English isn't the best either, so no problem. As long as we can understand each other, it's okay. We have the same software structure in every project we use, and this this software structure is recursive, and because it's a recursive design, we have a lot of recursive functions in it, like here, but this is easy. It's easy if it has a tree-like structure, then it's quite the same every time. Like here, you just have the function, and then you have a while, and you reuse this function, and that's all. So this is easy, but in the advent of code, sometimes it's yeah, I'm glad to see you too. As said before, thanks for the raid, Flavio, and I'm happy to see you. So I have coded a lot of recursive functions, but every time, every new, it's very strange for me. If I have some problem set and I use a normal iterative way, then I always know what I have to do. But if I have to solve something with a recursive function, I always have to think again. The Prolog programmers. Do you guys know VHDL? VHDL is a very interesting. The abbreviation is kind of perverted. It's VHDL for Very High Speed Integrated Circuit Hardware Description Language. It's a bit strange, but this is also very, very different than a normal language because everything you write is in parallel. This is a description language, a hardware description language for digital circuits, and in a digital circuit, everything is working in parallel. So that's very interesting, and you have to switch the thinking. I think, I don't know how it's in logic programming languages, but if you read the code of a VHDL stuff, then everything you see is in parallel, existing in parallel, and that's here you have to think in a very different way. I think this is similar than learning logic programming languages because it's a bigger branch. But this sounds interesting. I am a fan of logic stuff. I've never seen Prolog before. If we didn't visit a node before, then I want to visit it. I want to add it, push back to the list. At the moment, this isn't recursive. Node found. Init statement in selection available what? What is this thing talking about? Ah, yes. Okay. I have to write the stuff in a proper way. Cannot convert, hey, special for your viewers, primes and followers from my stream. What is this? I think this is this a bot? I don't know. So, cannot convert JSON value to const char. Key. .as string. I like to use the come on. String to const char, okay. Whatever. I could use a string reference instead, I think. I'm the C guy. kind of. So yes, I think this is working, hopefully. Okay, no matching function call for yes, that does make sense. So we have an iterator and we have a string key, whatever, and we say key is equal to that stuff. So the code is a little bit shorter than. So control reaches end of non-void function, yeah, fine. So I have decided to go a specific way because I haven't found it on. I always use the ifs in a negative way because I like it to see the code be vertically. So if not found, then I can use it. And then I would say a log inf log using node whatever key C string. I push back, return 0. Okay. I'm using node Belfast, using node Dublin, using node London. Okay. Now I have now we make the thing recursive. Call calculate shortest. Paw. Okay, let's see. I say u integer dist and dist shortest or dist minimum. I say the distance, the current distance is the next try to get the shortest path. I give this function my path. I give it the depth, and then I try to do this, and then I make a pop back. And I say if not dist minimum, then dist minimum is equal to dist, and if dist is smaller than dist minimum, then dist minimum is equal to dist. Let's see if this is useful. Okay, so now I have a special case, and that is if I go into this node, I check C++ Dragon. I'm a C++ Dragon. C++ is, I have worked a lot of years in C++, so C++ itself is easy for me, but I stick to the old standard, so I'm not, I don't know anything about the new functions of the new standards. There are so many keywords in the new standards, like I think I saw something like this, no discard, or I think it's looking like this, and I don't know what this means. I have heard about the keyword override. There is a keyword override in the new standards, and as you can see, it's green. This override function is for if you are overloading functions, then you can make sure that you use the right function. I don't know what this does, so there is a lot of stuff I don't know and I don't use, because I think actually it's not necessary. Do any of you guys have Telnet? In this stream we have a complete, today I want to make a relaxing coding session, but actually we have a project going on, and that is our gaming server. And this gaming server, you can join to this gaming server. Does anybody of you have Telnet? You can join the game Telnet with Telnet Nigelus testing USTO 4001. Yeah, that's a good combination. That's a very good combination. That's the key. If you write this in a console, if you have Telnet, you can join the game server, and in the game server we can play Connect 4. It's quite cool, because you can create the game and then we have a lobby, and in this lobby we can join Telnet Nigelus testing and you can join the server by pressing enter. And then we can start the game, and we can play Connect 4 if you want. So this is a spectator now, and only one player in the server, because it joined here as a player 1. And that's quite cool already. That's the main project of our stream, and the goal is to have multiple games, like how is it called, Battleship, I think, and some stuff, and then it's a multiplayer game. Here one team can have multiple gamers, for example, and then one team is the winner, and you go back to the lobby. So this is our main project, and that's quite cool already. But for today I just want to code a little bit. I want to practice the recursive stuff. for every recursive function, we need to have a state, an situation where we break the recursion. Thanks for the follows, by the way. A recursive function calls itself, but at some point we have to break the recursion. Every time I make a new recursive function, I make some protection code like this. I say if the depth is too high, then go out, then I have made some error, some endless loop. It's very easy to create an endless loop if you are experimenting with recursions, and the depth counter is a quite good way to protect yourself against the endless loops. So in this case, we don't have a case, a way to check if we want to enter recursion. It's if we didn't find any node. So we have a trace. We have a trace. We choose a node. If this node is not in the list, if this node is not in the list, we can we add this to the list. We call this function again, and then we remove the node at this stage. So if we push back our visited node, then we call this function, then we go into this loop again. With this I can visualize that the way it takes a lot better. As you can see, it's trying the Belfast node. It's using the Belfast node. Now we are in the next step. We are in the next depth. So I can also show the depth. This the level in which we are. Level. Well, I can't pronounce this word. That's very bad. So depth. So at first we are in this level 1. We are trying Belfast. We don't have Belfast in our trace yet. Then we can use Belfast. Now we are in the next level. We are trying Belfast, but we can't use Belfast because we are already in the Belfast step. Now we are trying Dublin. We can use Dublin because we don't have it in our list yet. Then again, as it seems that the recursion is working already, because the break of the recursion is done because of this if we can't find a free node because we have used all nodes. Okay, let's see. No, it's okay, no. If we go out, then we say here depth for end. So we even better see the path it takes. We go into depth 1. We're trying Belfast. We can use Belfast because it's not in the trace. We go to the level 2. We try Belfast, but we can't use Belfast because we have visited or started from Belfast already. Then we try the next one, Dublin. We can use Dublin, so we go into level 3. Now we are in level 3. We are trying to go to Belfast. We can't because we have it in the trace list already. We are trying Dublin. We can't. We are trying London. We can, and we go to level 4. And then here the recursion breaks because we have Belfast, Dublin, and London in our list. And that's cool. So now I want to add the calculation of the distance. And the calculation of the distance is done by like this. Distance, traveled, distance traveled. We say distance traveled at this point is 0. And now we make it optional. Like here. Now we have a travel distance, and we add if we choose a node, then if we choose a node, then we need to add the distance to the next node. So at first we don't have anything in our trace, so we are not in any node. So we are using a node. And we don't call it key, we call it destination, next node. For example, like this, using node, push back the node, this should be working. Yes, distance traveled. Now we have to use the distance traveled, the current node, the next node, and the current. I rename it node current, next node, node next. Yes, fine. And the current node using node whatever. That's the next node, and we want to calculate the distance. And we can calculate this distance if if we say if visited size, if we have a size, then our current node is visited.back. That's the last element. If this trace has an element, then if the trace has at least one element, then we can check at which state we are with the back, the last element of the list. At this point we are. If it's the first node, then we just go push it on the stack and we go to the next. If this list has a size, then we have a distance from one point to another, and we can calculate this distance and add it to the traveled distance, like this. Distance traveled is plus equal to the distances, that's our structure, from to. So from is node current and to is node next. As uinteger. And then using node let's see, traveled, let's print this variable, what we get. So let's see. I go through the structure, data structure. I say I'm trying Belfast. I can use Belfast. I have not traveled any distance so far, but now I have the next level. I try Belfast. Now I go to Dublin. From Belfast to Dublin, it's 100 and what? What's going on here? So, it's initialized as 0. Okay. Yeah, that's so now this should work. Okay. So I'm at Belfast. I'm going to from Belfast to Dublin. Then I traveled 145, and this is the end of my journey, and this end of the journey should be visible somewhere, but it isn't. Why? Because 155, let's see. This now. So let's see. I traveled 0 kilometers, and then I'm traveling 141. So I traveled. So we can better read this. So that's the sum. Now I add I'm at Dublin and I can only go to London because I have Belfast in my trace already. So I add 464. So the result is 605. Now I am at London and yes, using London. I go into level 4. I cannot travel to anywhere. 605. Okay. So next we go out to the next stage, one stage up. We left level 3. So I'm in level 2. And that's the second path we can use. It's London. So we add London to trying node London, and this means no. Haha. Yes, that's wrong. Because as soon as we have left the place, we have to decrement the stuff. Oh, come on. So let's see. Okay. And what do I want to return? What is the distance? The distance is this. Okay, we have to this variable is in fact this variable somehow. I think we just bool. Let's see. We say next found is false. If we have found a suitable node, then we can say using node blah 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 true, and if I did not find any node, then the distance for this path is in fact that one. if we did not find any path, then the distance we have traveled so far, he's saying 605. This is correct, but let's try it. So for the small example, it's okay. Let's see if it's working for the big example. Oh, yo. This looks very... I can't imagine that this is working, because this is our list. I don't think this is the answer. This would be very strange. Okay, it worked. Somehow it worked. Okay. Yeah, cool. Let's see what's the second part. The next year, just to show off, Santa decides to take the route with the longest distance instead. Okay, he can still start and end at any 2 different locations he wants, and he still must visit each location exactly once. For example, given the distances above, the longest route would be 982. Okay, so we will introduce a mode variable. Mode is 0. We say this result. This result variable is always set if it's not set, and then depending on the node, if mode is equal to 0, then we take the smallest. Otherwise we take the largest. So, and now we have uint8 mode is equal to 0. Okay, let's see. Then this doesn't need to be optional anymore, because we want to use it here as result. Yep. And that's the result 1, and now we say mode. The other mode is the second result. And we print the second result. And we try to check the small example first. That's not working because we have to add this variable to the recursion. Now we have 2 results, the smallest one and hopefully the largest one. And we try to use the big example. it's coded in a very inefficient way, but I don't care. So 804, that looks quite small. Oh, please, come on. Oh yeah, easy. Cool, this was day 9. This was day 9. And that's it. Cool. We can, for one moment, try to remove all the debugging stuff, because calculate shortest, because then we are able to see the data structure. As you can see, it was calculated a lot faster because the output is very slow, and this is the input. These are the input lines. We can travel from here to here, we can travel from here to here, and this is the past data structure. And actually you can see that every node has the same degree. So we can travel from every node to 1, 2, 3, 4, 5, 6, 7 places. And this seems to be very interesting, because it's a graph where every node has the same degree. 7 here and 7 here. And there is, as in the Eulerian path, for the Eulerian path there is some restriction of paths, of graphs that where you can make such an Eulerian path. And I think the restriction is definition, properties. If and only if every vertex has even degree, that's the requirement for an Eulerian path. And the degree is how many edges are connected to a node. The degree of a node is how many edges are connected to one node. The degree of the graph itself is the degree of the highest degree, I think, of all nodes. For example, this node has degree 2, this node has degree 4, 4, 4, 4, and 4. And if every node has a degree, an even degree, then an Eulerian path is possible. And in this case, for example, we have more restrictions. Has and all of its vertices with non-zero degree belong to a single connected component. Yeah. That's for directed graphs. A directed graph is if we can go from one node to another just in one way. But I think this is also, is this possible? No, I think not. You can from this point to this point. Let's see, from here to here, from here to here, to here, here, and here. So there is some restriction. Which graph can be has an Eulerian path and which graph doesn't. And there is also a restriction for Hamilton paths. A complete graph with more than 2 vertices is Hamiltonian. And I think it's yeah, there are some types of graphs that are fulfilling this requirements, and this graph also seems to fulfill the requirements. It's not fully connected. Fully connected means, I think it's not fully connected. Let's see how many nodes do we have. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 nodes. Yes, no. Then this is a fully connected graph. If we have 8 nodes and for every node we have 7 possibilities where we can travel to, then we have a fully connected graph. That's a complete graph. This is looking this structure is looking like that. 1, 2, 3, 4, 5, 6, 7, just with one node more. It's looking like, oh, so it's quite similar. And the reason why is because we can travel from here to here, then here, then here, then here. Or in this example, from here to here, to here, to this node, to that node. So we have the possibility to visit every node. If somebody is listening, still listening, then I can recommend a very good book. That's called Graph Theory. It's a book. It's called A First Course in Graph Theory. It's a very, very, very good book. Because the examples are very easy. It has some special kind of language. You need to get used to it, but it's for a math book. It's quite good readable, and it has a lot of cool examples in it. So you see why you what you can do with this graph theory stuff. So yes, that's cool. That's amazing. Okay, that's amazing that this example was working like a charm. So we have 1 hour and 20 minutes left, so I think we can do another example. Oh. Yes, AOC 2015. I think this was day 9. Cool. So let's see what is in prologue. Mother-child. Mother-child. I think this is a relation mother-child. Sally is the child and mother is the Trude is the mother. Father-child. Tom, Sally. Tom, Erika. Mike is Tom. So there must be a... Oh, cool. A sibling of X and Y is... that's looking cool. A sibling, the relation X epsilon is true if X and Y has the same parent. if this is true and this is true. Parent child of. Yes, the parent is if it's a father or if it's. This is an or statement. If this is true or this is true, then this is true. Are these two siblings? I want to try this. So, let's see. What is the ending, the file ending of a prolog file? The first dot prolog whatever apt install svi prolog. Can I install this? Oh, cool. This is a very interesting example. Prolog Befehlsübersicht. Zuerst mit die Wissensbasis erstellen und dann freiwillig mal APL. PL. It's not PRA, but PL. Installed. So, the first. We have to add, I think, this. Now we start the prologue with the facts. And the facts are this. Okay. And now I can check. This is the command prompt, it seems. I can check if siblings, if this relation is true. Sally and Erika. I missed. Action. Q. No, I want escape. Oh. Continue. Exit. I have forgotten the dot, I think. Sibling. Sally. Erika. Point. True. Cool. That looks kind of fun. That's quite cool. Actually, this is quite cool. Loops and recursion. So we could this. A simple example Turing machine is specified by the facts. Right, and stay cool. Turing, blah blah blah. But that's the language itself seems to be very interesting. So let's have a look. Main. So let's see what is day 10. I think. Let's see. I remove this and I Mason build native and the build native gaming. Okay, perfect. I have input. Yes. I have the input files. And I remove all the stuff in day 10. That's fine. I don't need that stuff. I don't need that. This and this and... Okay. Just print the lines of input 1. Okay. So let's see. Today the elves are playing a game called Look and Say. Look and Say sequence. Cool. They take turns making sequences by reading aloud the previous sequence and using that reading as the next sequence. For example, 211 is read as 1, 2. Is read as 1, 2. 2 ones, okay. Which becomes 1, 2s, 2 ones. Okay. Strange. Look and say sequences are generated iteratively using the previous value as input for the next step. For each step, take the previous value and replace each run of digits like 111 with the number of digits 3 followed by the digit itself. Okay. For example, 1 becomes 1 1. 1 1 becomes 2 1. 2 1 becomes 1 2 1 1. Starting with the digits in our puzzle input. Apply this process 40 times. What? Ah, cool. Ah, this is the puzzle input. Starting with the digits in your puzzle input. Apply this process 40 times. What is the length of the result? Okay. So let's see. We declare an input. Yes, and the input is 1. And let's make a string. Pooh. no, just let's make a function. String, very easy, not look and say const string reference input and uint 32. Count is 1, whatever. Now we need a count. So we have one line, and the result 1 is equal to look and say of a line, and we try this example 1, 2, 3, 4, 5. Now 4 times. This is 4 times, and this is a string res1, and the result D is the result size. Okay, so we have 2 variables, u and v, and for the first thing is we have a string out. We say u is equal to 0, u is smaller than count, plus u. And the next 4 is v is equal to 0, v is smaller than in.size. What do I do? So plus v. Oh, that's not easy. But I make it easy. I make it easy for me because I skip one step, and I say this string has 2 elements per default, and I say char last is equal to in 1. And then I do this char last is in 0, and then I can start from the second character. I make it easy for me. And as long as this is smaller than the string size, then and I need a count. I need a counter for the a running count of how many times count last. How many times did I see the last character? This must be 0 here, and then I increment if in at the position v is the same as the last character, then we can say plus plus count last and then continue. But if it's different, then we have a new character. Then we have a new character. If I repeat this, okay, let's see. That's interesting. Okay, the result of each iteration will be printed out in log result number is count u of is out C string. Then here I say in is out, and then I return out. If the digit has changed, then I have to print the digit out must be cleared. It's very inefficient. So never mind. I want to add this integer out plus equal to is this working? I don't know. Let's see. Integer to array can't last. Let's see if this is doing something. Was not declared. E to S maybe? I have to Google the most basic things all the time. Easiest way. Come on. ToString. Yes, and ToString. I've used it today. What the hell? ToString. Out, passing, const. Yeah. Whatever. Okay. Line 1. Input at okay, input at this is working. How many? Ha, perfect. Input at 0, 4 is, I just need 3 iterations now. The input. Yeah, so I need a last one here. Okay, I have one once. No, I have 2 ones. Oh, come on. To the count plus and out plus equals of 4. String 1 of last. Two ones. No, this is not working. Yeah. So I can remove this one again and make 4 iterations. So, come on. I have one. Input at first. Okay, fine. How long is this thing? I have at least one character. I have at least one character. Okay, let's see. This can't be true. Oh, okay. Okay, let's see. I'm not thinking straight. If I enter this for loop, then I iterate one time. I have one. The last character is initialized with 0, so this is increasing the count. Okay. No, it's not increasing the count. Let's make something. Let's make it different. If it's unequal, then come on. This should be easy. Should be very easy. I think I need one more sip. I should initialize this as 1. I think. I say if not in size, return. If it has a size, I can start with the first one. Okay. If I can start with the first one, then the last character is in 0 and the last count is 1. Now this should be fine. Okay, as long as this is the same, if the last character yeah. This is bad. This can't be true. Now this should be fine. Okay, let's see. Come on. I have 1. And the result is 1, 1. This can be this out. Come on. The string. Come on, C++ string. The string constructor. Yes, all the time I am always. No. This is working. First the size, the number of characters, and then the character itself. That's okay. That seems to be fine. But why isn't it working? Count last. Plus equal. I need to. There must be two characters at this point. I want to solve this puzzle before 11 o'clock. This must be possible. So, if I have seen one different character at this point, then we must have at least one of this last character. Okay, that's fine. I think that's fine. But why this should work already? Let's see. Okay. 3. It's not going into the for loop. That does make sense. 3, that does make sense. Three isn't adding anything to string count last. No. This is yes, as expected. The last character must be 1. No, the last character. The last character. What? Zero. Why is the last character 0? Because of yeah, sure. Oh, come on. So. Hopefully. Hopefully. Yes, I think this is it. Okay, let's see. Okay. Remove this. Yes, that's fine. Okay, oh, come on. Okay, this is a bigger result, so I make warnings. As you can see, it's very, very beautiful what I'm doing. So the first result is at this point. I have one. Yes, that's the character 1. The character 1. I should be able to remove this. Yes, that's fine. So I have 1 times the character. Count last. Come on. this count last variable is way too high because of what? Yes, this is working already. 2000 blah 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 1. But the stupid count last. What is count last? Okay, this looks this looks okay. So let's see. I have one. But this is the result. Okay. This is the input and this is the output. I have 1, 1. Now I have 2 ones. Now I have 1, 2 and 1, 1. Now I have 1, 1, 1, 2 and 2 ones. Oh, come on. That was where it becomes okay, let's see. Let's make one iteration more. So this is the result of this. Okay, perfect. Oh, come on. So this was it took longer than it had to be. So our input is now and we process this input. Oh, this will take a long time, I think. 40 times, because we are copying the string back and forth, so I think this is very bad. Actually, this is shorter than I thought. Okay, let's see. What? Huh? I expect this to be longer and longer. 1 3 2 1s 2 3s 2 2 2 1s 1 3. Okay, this is fine, but this is the result of stage. Huh? This can't be the result of this. Let's see. That looks very strange. Huh? What? Let's. Huh? What? Okay. I don't know what's going on. I see every result. Ah, I'm stupid. That's fine, that's fine. This is the size of this string. Okay, that's fine. That's cool, that's fine. Okay. Part 2. Neat, right. You might also enjoy hearing John talking about this sequence. That's Conway's game of. Now, starting again with the digits in your puzzle input, apply this process 50 times. What is the length of the new result? Okay, let's see. The same puzzle input. So result 2 is making this 50 times. Res 2 and then okay, that was easy. Just increasing the number. This video I think is interesting. Maybe look, insane numbers. John Conway. Interesting. Yeah, cool. This was day 10. This took way longer than it had to be. I'm ashamed, but because it should be easy. Whatever. Okay. AOC 2015 at day 10. We have 40 minutes left. This means maybe we can add another Mason build native. I'm too lazy to create the template file. Okay. Santa's previous password expired. And he needs help choosing a new one. Okay. To help him remember his new password after the old one expires. Santa has devised a method of coming up with a new password based on the previous one. Corporate policy dictates that passwords must be exactly 8 lowercase letters for security reasons. So he finds his new password by incrementing his old password string repeatedly until it is valid. Incrementing is just like counting with numbers. And so on. Increase the rightmost letter one step. If it was set, it wraps around to A and repeat with the next letter to the left until one doesn't wrap around. Unfortunately for Santa, a new security elf recently started and he has imposed some additional password requirements. Passwords must include one increasing straight of at least Password must include one increasing straight of at least 3 letters like ABC, BCD, CDE, and so on up to X, epsilon, Z. Okay, they cannot skip letters. ABD doesn't count. Okay. Passwords may not contain the letters I, O, or L, as these letters can be mistaken for other characters and are therefore confusing. Passwords must contain at least two different, non-overlapping pairs of letters. This was one of the 2022 requirements. For example, meets the first requirement because it contains the straight HIJ but fails the second requirement because it contains I and L. Meets the third requirement because it repeats B and FF but fails the first requirement. Fails the third one because it only has one double letter. I will reuse a code. Ha. This was in day 5. Okay, well, let's see. We can reuse code of the same. Of the same year. That's interesting. Okay, let's see. Let's create a function. Oh, come on. Let's not create a function. I think this is easy. This is a short one, hopefully. So let's just we can use okay. So forbidden. Has forbidden. How is this calculated? Okay. What is this? How is calculated? Double. Double. We have double if. Oh, this and huh? It's non-overlapping, I think. This is overlapping. That's bad. Come on. Come on. Okay, whatever. Let's make a new one. Okay. Okay. But at least we can look at this code. Bool line check. What is the question? What input should his next password be? Your puzzle input is. Oh, come on. Okay, we need to have three functions. Oh, come on. Line check, const char pointer p line. String or let's say string password check string password string reference const string reference password return false. We have half an hour. Let's see if we can do this. We need a password check. We need a string. We need a string new password calculate, and we have a const string reference of password old, and we say password new calculate. And the result string result1 is res1 is equal to password new calculate from the line. So, and the result is result c string. Okay, fine. And we do two steps, and this is a string password increment string const string reference password old. We say string password is equal to password old, and we say do. I've never used a do like this. Okay, do while not pv check password okay. Password. And I say the new password is the password increment of password old, and password old as long as we have to increment the password at least one time. I want to switch this. I can't read this code. While we do the calculation one time too often, but that's okay. If the new one is this is initialized to 0. If the new password is not okay, then increment another one. Actually, I've never used this like like that. Okay. Do I need a semicolon here? I think. Yes, absolutely. Okay, perfect. So, do something. We increment the old password and get a new password. The old password is the new one. This looks so strange for me. I don't know why. Okay, let's speed. Okay. I don't need this. I just don't need this variable, I think. I think that's okay, because we will increment pv new, and we will return pv new, so we actually create a copy of the old password, so it should be fine. Okay, let's see. We are incrementing yeah, that's fine. While not okay, but it is okay, so it's now we should get the same password. Okay, let's see. $15. We have 20 minutes left. Poor. I have to code very quickly. Yes. Okay. We have this line, and the result is make a new password, and the old password is the line. Okay, fine. We get a new one. We increment, and this. Okay, perfect. Okay. Now we have to increment. At first, we need to implement the increment function. Incrementing has old based on the previous one. 8 lowercase letters for 0, so that he finds his new password by incrementing his old password string repeatedly until it is valid. Incrementing is just like counting with numbers. XX, XY, XZ, A and B, and so on. Okay. So I have to start, I have an index. U integer 32 index is the string length of the size PV old minus 1. That's the last index I can use. Let's do something. Okay, let's make a character. Set this character to pw new of index. This is the rightmost character. Then we increment this character. And then we have two situations. If the character is smaller or equal than set, then we are fine. So we break and we have calculated the new password. But if this character is bigger than set, then if it's smaller, then we can write this character to the index. But if we can write this character to the index and return. But if it's bigger than set, then the character is equal to A. We write this new character to the index. We decrement the index. Is this working? I don't know. Let's increment the stuff. I increment the first index. If this was fine, then write this character to the index and go out. That's the cool case. Okay. Now, but if we have reached the end, we go to the beginning, and write this instead. We decrement the index and let this while do another increment of the next lower index. Okay, let's see. I think this is it. So that means we just increment, we should be able to make one increment. So we had A, now we have B. Okay, seems to be fine. Okay, now we have a new password. We have 15 minutes left. 15 minutes left. Come on. We have to check if the new password is okay. So we make a integer u. U is equal to 0. U must be smaller than, oh come on, the size of the new password plus u. If anything is wrong, go out. So that means if the size is 0, then it's definitely wrong. So we filter the strange case, the exception case. So now we can say the last character was the first one, and we can start. Oh, that's bad. We have to be careful. No. Let's do it like this. Because we have to say pw new of u. And now we have to say if the character is equal to I, or the character is equal to O, or the character is equal to L, then we are sure that this password is wrong. Actually, we can say if the size is not equal to 8, then we can return false. We can check every letter. If it's a forbidden letter, then we have to return false. These are the requirements. So we have the first requirement done. Must include one increasing straight of at least 3 letters. Oh, come on. So let's say if bool has straight is false. If not has straight, return false. If u is bigger than, come on, or equal than 2, then we can check if we have a straight line. So if pw new of u minus 2 is equal to pw new of 2 u minus 1, -1 and PW new of U minus 1 is equal to PW new of U minus 0, whatever, then we have a straight thing is equal to true. I think this is fine, okay. I will use a line like this. The password, we calculate some stuff and then we show if it's this was the password, the password new.cstring. We have 10 minutes left. Come on. Has straight last if you then your last is this one, that's okay. No, this is wrong. This is fine, but we can check only if you and the character is equal to the last character, then we have a pair. Bool has a pair, has pair double, if has pair, then has pair double is true. Okay, see? One increasing straight, must contain blah blah blah. Okay, has pair double. If not has straight, go out. If not has pair double, then go out. We have to be careful. Oh, come on. Because this would be overlapping. This would be overlapping. And not delay pair check. I want to delay this check for one character. Oh, 5 minutes, come on. If we have a triple A pair, then we would detect a double pair, but that's not allowed. But it's allowed a quadruple A pair. That's allowed. So we cannot check if the character of the pair is different. So we actually have to delay. The next check is not allowed. So when do I have to? I don't want to. Come on, whatever. I didn't want to make another if here. If the check is enabled by u is unequal, is not 0, and the character is the last character, then if the check is not delayed, then we can check it. If this is true, then we have a pair. We delay the pair check, and if you and not this, and disable the check as soon as we have found a double pair. So if this is enabled and it's okay, then if it's not delayed, why is this not working? Because we miss okay, it's incrementing. It's incrementing. And it's doing something. Come on. Oh, we have 1 minute left. Oh! We didn't make it. CDE. Let's move this line to here and check why it's fine. It's fine because it doesn't contain IOL. It has CC and CC, non-overlapping. It contains at least 2 different non-overlapping pairs. Two different. Oh, okay, wait. Chair pair 1. This is okay, I think. So it has a pair, and the character for this pair is this one, and if pair is double and this is and is not equal, then pair 1. We have CDE and we have 2 pairs and it's 8. Oh, come on. Okay, that's it. We have failed. Different non-overlapping pair. What if I use an F here? This is the last try. If this isn't working, then we had three tries, and that's okay. Not F, but A. This should be fine. As soon as we have reached this E, C, D, E, if we have D and Z, then the next increment would be E and A, and this should be a valid password. So, okay, that's it. So, unfortunately, we didn't make it. It was quite fun, and hopefully we see us next time. The Prolog language seems to be very cool, and now we are raiding somebody. Let's see who is still online. The Brutzler, Jimmy Peak, Sorin Dev. What is Boonben? Boonben is making the... that's a cool series. Boonben is making a concept for his new game. The Brotzler is making soldering stuff, and Arte Birklaus. What is Arte Birklaus making? A 3D engine and FPS first-person shooter in C++. Ah, that sounds to be... Let's see. JV Pig is fighting against is catching a raider. Oh, cool. Let's see. So, guys, I hope I see you on the other side. Alright. Arte Birklaus. It was fun. Next time is on Tuesday.